Hi there, hope you have a fantastic day. This lesson, I will go through 2024 HSC paper with you. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question number 23. First of all, we know that the mean is 85. And the standard deviations is 15. By calculating a z-score, find the percentage of scores that are between 58 and 70. So let me just work out the z-score for both first. So we know that z-score, z is x minus the mean over the standard deviations. So keep that in mind. So for x equal 58, so z is equal to x, which is 58, minus the mean, which is 58, divided by the standard deviations, which is 15. So that is 0. For x is 70, x is 70, so that means z is equal to 70 minus the mean, that is 58. We divide by the standard deviations, that is 15, which is equal to, so I just go fractions, 70 minus 58 divided by 15. So there you go, 0.8. 0.8. So this means that we need to find the probability, okay, between 0 and 0.8. So that is equal to, so from the table, so we know that 0.8 for z, that is probability of z less than 0.8. That's what that meant. So that is equal to 0.7881. But we need to find the area or the probability between 0 and 0.8. So that means from 0 to 0.8 is this. So we have 0 here. So that means 50%. And then 0.8 means this area. So this means that between 0 and 0.8, we just need to work out by 0.7881 minus 0.5, because so this area here is 0.5. So that is equal to 0.7881 minus 0.5. So that will give me 0.2881. There you go. But we need to answer in terms of percentage, which is times by 100. So that is equal to 28.81%. There you go. Part B. We need to explain why the percentage of scores between 46 and 70 is twice the answer in part A. So let me just work out the z-score for 46 first. So for 46, so z is 46 minus the mean, that is 58 divided by 15. So that is equal to, so I just go fractions, 46 minus 58 over 15. So there you go. That is negative 0.8. Negative 0.8. So we know that the area between, let me draw this out. So that is 0. So the area between negative 0.8 to 0 is the same as 0 to 0.8. So therefore, the area between 46 and 70 is twice the area in part A. That's all. So therefore the percentage, so there you go. You can say something like the area between 46 and 58 and 58 and 70 are the same. So therefore the percentage between 46 and 70 are twice the answer in part A. So you can say something like that. Part C. By using the value in the table above, find an approximate minimum score that a candidate would need to be placed in the top 10% of the candidates. So top 10%. So that means this is above top 10%, just above, all right, this one. And for 1.2, this is just below, okay, so approximately, so that is Z is from this onward. So that is Z is the minimum score for Z is approximately 1.3. So in another word, because Z is from 1.3 onward, so that means 1.3 standard deviation above the mean. So the score will be equal to the mean, that is 58, plus 1.3 of the standard deviations. So that is 15. So we times 15. So that is, so we just go 58 at 1.3 times 15. So 77.5. So therefore, the minimum score is approximately 77 or 78. Okay. So therefore, there you go. Question 24. So we know that the annuity is $80. The interest rate is 6% per annum, but then we need to compound it monthly for 24 months. So let me just sort this out first. So that means R is 6%. We divide by 12 because compounded monthly. So that means 0.5%. And N is 24 months. And we need to work out the final amount at the end of 24 months. So we know that the first amount, A1, because Jack deposit at the beginning of the month. So at the end, he'll get interest. So at the end of first month, so he'll get 80 times 1. Now 0.05% is the same as 0.0, we divide by 100, 0.5. So that means times by 1.005. So keep that in mind, okay? Remember, future value is present value, 1 plus R power of N. Keep that in mind, okay? That's where I get it from. And then A2, at the end of second month, the A1 will get interest as well, plus the second month also gain interest. So the first month, that means A1 times 1.005, and we add IT, and we add IT times 1.005. So let me change A1 is this IT times 1.005 and times 1.005. So that should give me square. So there you go. Now A3 is A2 times 1.005 at IT times 0.005. So that means A2 times 1.005 will give me this IT times 1.005 power of 3. We add IT times 1.005 square, and we add, let me just clear this first. So that is add IT times 1.005. And then we need to do that for 24 months. So that means A3, let me just rewrite in different order. So that is the same as 80 times 1.005. We add 80 times 1.005 square. And we add 80 times 1.005, part 3. I just write ascending order, so it's easier, that's all. Now A24, A of 24, that will give me 80 times 1.005 at 80 times 1.005 square. We add all the ways to 80 times 1.005 power 24. Keep that in mind, the pattern here. If it's 3, this is power 3. So 24, this should be power 24. So now I just use geometry series to add this series together. So that is equal to, and we know that Sn is A r power n minus 1 over r minus 1. I just use this rule. A is this. R is 1.005. Keep that in mind. So that is 80 times 1.005. That is A, first term. R is 1.005 power 24. That is n minus 1 over 1.005 minus 1. So that is equal to, so I just go fractions 80 times 1.005 brackets 1.005 power of 24. We minus 1 and we go down 1.005, we minus 1. So there you go, $2,044.73. So 2044 and 73 cents. There you go. Part B. Instead of work out the future value by using geometric series, we could also use the table of future value interest factor for an annuity of $1, and then we can work out the future value as well. So we need to work out value of A, that is future value interest factor. So in another word, we just go like this. A future value that is 2044.73 is equal to A times 80. Okay, because this table here is annuity of $1. Because annuity of $1 will give us A. So now the annuity is 80. So we just times by 80. So now what I do, I just divide this by 80 and I divide this by 80. So that should give me, I just go answer divide by 80. That would do. So there you go, correct to 3 decimal place, 25.559. So therefore, A is 25.559. There you go. Question number 25. So we need to find the value of h so that f of x is a probability density functions. So for probability density functions, so we need to find the area between 0 to h. So the area is equal to 1. Okay, f of x. So in another word, we just find the area of f of x between 0 to h. So 1 minus x over h dx is 1. So keep that in mind. So now what I do, I just integrate this. So integrate 1, give me x. Minus integrate x, give me x squared over 2. So in another word, so it's x squared over 2h. And that is from 0 to h. Give me 1. So now I just substitute the value in. So in another word, h minus h squared over 2h minus, if we substitute the 0 in, minus 0 is 1. So now this h, we cancel with this h. So that means h minus a half of h give me a half of h, which is equal to 1. Times 2 both sides, so therefore h is equal to 2. So there you go. Part B. By first finding a formula for the cumulative distribution functions, sketch its graph. So work out the cumulative distribution function first. So we know that capital F of x is integral from a to x, because a is 0. So to x, f of x dx. So f of x is this value here. So that is h is 2. So 1 minus x over 2. So 1 minus x over 2 dx. So that will give me x minus x divided by 2. That means x squared over 4. From 0 to x. So that will give me x. I substitute x in. So x squared over 4. And we minus 0. So that's the same. So this is cumulative distribution functions. So now we just need to sketch it. So to sketch this, we know that it is a parabola. Intercept is this. Let me just quickly make note on this. So we can find the x-intercept. So x 1 minus a quarter of x is 0. So that means x equals 0, x is 4. So that means the maximum turning point is at x equal to 2. So let me just write this down. So this is x, this is f of x. And the x-intercept is 0 and 4. And we know that the maximum at x equal to 2. So this is 2 here. Something like that. Okay. So that is 1. And from 2 onward, f of x is 1. So there you go. This is cumulative distribution graph. Part C. Find the median of the probability density functions f of x. Correct the 3 decimal place. So in another word, the cumulative distribution equal 0.5, because median is where the probability is equal to 0.5. So that means f of x equals 0.5. Cumulative distributions, okay? So that means we have x minus x squared over 4. X minus x squared over 4 is a half, or 0.5. I times 4 on both sides. So that means x times 4 will give me 4x. And minus x squared a half times 4 give me 2. Then I just rearrange it. So it should give me 0 equal, I move this side, so become x squared. I move the 4 on that side, become minus 4x. And then plus 2. Then I just use completion of squared to solve this. So that is the same as x minus 2 all squared, a half of the 4. And if I expand this, it will give me exactly the same up to here with the 2 square extra. So therefore, I need to get rid of this 2 square, so which is 4. And these 2, I just copied that out. Equals 0. So now, that will give me x minus 2 all square minus 2 is equal to 0. So I move the 2 on that side. So that is x minus 2 all square is 2. I take square root on both sides. So this means that x minus 2 is plus or minus square root of 2. And I move the 2 on that side. So that means x is positive 2 plus or minus root 2. So there you go. That's the answer. But then x is between 0 to 2. So therefore, your actual answer is x is 2 minus root 2. So there you go. Cannot be plus root 2. Otherwise, it's more than 2. Okay, keep that in mind. Question 26. 25 years ago, Phoenix deposited a lump sum of money into a new account, earning 2.4% interest per year and compounded monthly. So this means that the interest rate must divide by 12 because it compounded monthly. So let me just write this down here. So R is 2.4%, we divide by 12. That is, I just go 2.4, we divide by 12. 0.2. But then the annuity table give us in terms of decimal, so I just divide by 100. So there you go, 0.002. So 0.002. So that means it's in here. So keep that in mind. Now, Phoenix made the following withdrawals from this account. So $2,000 at the end of each month for the first 15 years. And $1,200 at the end of each month for the next 10 years. So that is starting at the end of 181st month. And we need to calculate the minimum sum that Phoenix could have deposited in order to make these withdrawals. So that means 2,000 for the first 15 months. So let me just draw the timeline first. So this is from 0 to 25 years. So the first 15 years, Phoenix withdraw $2,000. And the next 10 years, so he withdraw 1,200. So if you think about it, we can interpret like this, okay? So for 25 years, he withdraw $1,200. And for first 15 years, he withdraw $8,000 extra, okay? So this is here. So 0 to 15, he withdraw $8,000 extra. So if we add this up, will give us 2,000. Okay, so that's how you interpret it. So now we know that for 25 years, so N is 12 times 25. That should give me, so just go 12 times 25. 300. So there you go. For 300, so that means present value for this annuity is $225.43. So let me write this down. So that means for annuity of dollar, 225.43. So $225.43. That for a dollar of annuity. So now the annuity is $1,200. So that means times by 1,200. And then we need to add the annuity for $800 for 15 years. Now for 15 years, N is 15 times 12. So therefore, 15 we times 12. 180. So that means for 180 for N, so the annuity for a dollar is this. 151.036. So 151.036. And we times by the annuity, that is $800. So that should give me, so just go 225.43. We times 1,200. Then we add 151.036 we times 800. So there you go, $391,344.80. 391,344.80. So there you go. Now question 27. So we need to differentiate x squared times 10x. So we use product rules. So y dash equal, we differentiate the first functions, give me 2x, and we times by the second functions, 10x. We differentiate the second function, so differentiate 10, give me sec square of x. And we need to time by the first functions, that is x squared. So now we just need to tidy this up. So that is equal to 2x 10x plus x squared sec square of x. So there you go. Part B. Hence, find the integral of x 10x plus 1 power 2 respect to x. So first of all, we need to somehow integrate this that relate to part A. So now the way to go about this is I can remove the bracket first. Okay, so let me just remove the brackets. So if I go x 10 of x plus 1 square, so that should give me, so I just expand this out, give me x squared 10 square of x plus 1 times x 10x and double, so give me 2x 10x, and we add 1 square. So otherwise you can just expand it manually, so just remove 2 brackets. Okay, so now let's see, we have this term here. So what I do, I convert 10 square somehow becomes sec square of x. So that means we know that the trig identity cos square of x plus sine square of x give me 1. If I divide by cos on every term, that become 1 plus 10 square x 1 over cos of x becomes sec square of x. So there you go. So this means that we just move the 1 on that side become minus. So let me just write this down. So that is x squared, that becomes sec square of x minus 1. And we add 2x 10 of x plus 1. So there you go. Now what I do, I just remove the bracket first. So that become x squared sec square of x minus x squared. We plus 2x 10x at 1. So let me just rewrite in the same order of this. So now that becomes 2 10x. So that is 2x 10x. We plus x squared sec square x minus x squared plus 1. So this means that if we integrate this one here, it will give us x squared 10x. So keep that in mind, okay? So now what I do, I just rewrite this out underneath here. So that is equal to integral of 2x 10 of x at x squared sec square of x. Let me just draw a line here so you can follow with me. And we add integrations of negative x squared plus 1. We can write like that, dx. And of course, this is dx as well. Let me just clear this. So this is dx. So this will give me x squared 10x. So that is equal to x squared 10x. And if we integrate, negative x squared will give us negative x power 3 over 3. Integrate 1, give me x. And don't forget, we add a letter c, a constant. So there you go. Thank you so much for watching. Bye.